Okay, I've just been blinded by bright lights, which is my subtle sign that it's time to get started. So hello everyone, I'm Ben Armstrong, Hyper-V Program Manager, here today to talk to you about what's new in Hyper-V. But before we get started, how's everyone going? Have we had a good first day at Tech Ed? Happy to hear that. I have to say, I've actually been involved in a lot of the behind-the-scenes planning for a lot of the Hyper-V demos that you've seen coming up today. So a lot of the keynote stuff and so on. So it was great to see those demos actually go off without a flaw. I do ask that you would make appropriate small sacrifices to appropriate gods, because my session today easily the most complicated set of demos that I have ever done. So fingers crossed, this is all going to go well. And one thing I will say going in is I was a good person for once. I got my session planned well in advance and I met all the deadlines. And so unfortunately, while I was building this, I didn't know what demos they were going to have in the keynotes and so on. So I do apologize. We are going to have some demos that cover things that you've probably already seen today. But hopefully I can go a bit deeper, give you a bit more context, and give you some extra information about what's going on. So with that in mind, let's get going. So first thing, you've probably heard this mentioned a lot. We've had a lot of positive feedback around Hyper-V in 2012. Really happy with that. And it's one of the things I cannot stress this enough, is that most people that I talk to have missed something that we did in 2012. I'm amazed, even today, I'm talking to people, they're coming to me and saying like, hey, I've got this problem, I want to solve this, and we're talking through it, and I'm like, oh yeah, with the new network virtualization, that solves that problem. And they're like, what? I'm still talking to people about just how awesome SMB 3.0 is. So one of the things that I would really encourage, honestly, the first thing I would encourage is, if there's anything that you don't know how to do with Hyper-V today, come by the booth sometime this week and have a chat to us. I'm going to be there after this event. I'm going to be there most of tomorrow. So come and pick our brains, and chances are we can figure out a solution for you. But apart from that, go back and brush up on what we announced last year. It was a big year for us, and I'm sorry to say we're not slowing down, so it's another big year for us this year. The next thing you've heard mentioned a couple of times, but I have to mention it again because this is something that we're actually really proud of on the Hyper-V team, is we just recently came out with the announcement that we had the Windows Azure IaaS offering that is running on stock Windows Server 2012 Hyper-V. And I think that's really cool for two reasons. The first reason is, well, obviously it means we have a great compatibility story here. You have Hyper-V on-premise, you want to use Azure services, yeah, it's the same underlying platform, you can move it back and forth. But the second thing that I find more interesting about this is I have lost track of the number of people that I've talked to who have been looking at cloud computing as an either-or proposition. They've been looking at cloud computing and going, do I do private cloud or do I do public cloud? And they've been going into this with a mentality of, I'm going to choose one, and then I'm kind of locked into that model. And that's absolutely not the case. It's something that we're very committed to, is the concept of being able to choose the right cloud solution that makes the right sense for you at any given point in time. And having our private and public cloud offering built on the same platform really enables that. So that's really exciting to see. And of course, pretty diagram. You've probably seen this a couple of times today, so I'm going to jump forward. So this is a big release for us. I know that a lot of you, actually, let's do a show of hands, because it's been a long day and I like some audience interaction. How many people came to this event honestly expecting that this release of Windows Server was going to be pretty much a service pack? About half the people. It is not a service pack release. There is a huge amount of features in here, and a lot of things that are really going to change the way you think about doing virtualization, about the way you think about doing cloud. So when we finished up on Windows Server 2012 and we started working on 2012 R2, there were a couple of big areas that we on the Hyper-V team looked at. The first area was, okay, we've got a great virtualization platform here. What can we do to really forward the art of server virtualization? What can we do that's not necessarily about lining up with big end-to-end scenarios? I'll talk about that later. But what can we do that's like, hey, let's really push forward here? And there are a couple of things that came out. The first one is building a new type of virtual machine. We call this the Generation 2 virtual machine. So in Hyper-V and Windows Server 2012, when you create a virtual machine, you're going to have the option to create a Generation 1 virtual machine, which is what you're using today with Hyper-V in 2012. But you're also going to have the option to create a Generation 2 virtual machine. So what's this about? Well, for the longest time now, I've been doing virtualization for just over 10 years. And when we started out doing virtualization, people didn't get virtualization. Virtualization was kind of this novelty, this interesting idea. So one of the things that we had to do was we had to make a virtual machine that looked just like a physical computer so that all the various operating systems and software could run on it without having to know that they were in a virtual machine. Well, that was great in the late 90s. It's now 2013, and virtualization is part of our lives. I talk to countless people where they say, we get new server workloads, we virtualize first. If you don't want to be in a virtual machine, you need a darn good reason to not be in a virtual machine. We have been working on Windows to make Windows fully aware of the fact that it's in a virtual machine. And so a Generation 2 virtual machine is where we basically take away all the cruft and the legacy support that we had for faking looking like a physical machine, and we build just a virtual machine. So I'll talk more about this in a demo later on. There are some restrictions on this today. It's a new platform. We have a limited set of supported guest operating systems. So we only support Windows 8, 2012 later, 64-bit. But I'll show what this looks like and talk about some of the advantages to Generation 2 virtual machines. The next thing we've done is we've built the enhanced VM interaction. And I'm not going to talk much about this now because it's more fun to demo it. So I'll get to demoing it in just a moment. And the final thing that we did that kind of falls under the, advancing the art of virtualization was the automatic activation feature. Personally, I love this feature. I think it's a really powerful one. When back in Windows Server 2003 R2, we realized that one of the things that was most important to people from a value point of view was licenses for virtual machines. And Windows Server 2003 R2 was the first release of Windows Server where we said, you know what? You buy data center, we'll give you unlimited licenses for running Windows Server inside of virtual machines. And a couple of interesting things happened as a result. One, we had more sales of Windows Server 2003 R2 data center than we'd ever seen before. The sales for that just went through the roof. People really loved that. And we got to a stage where with Windows Server 2012, the only differentiation between the SKUs is now how many virtual machine licenses you get. But one of the big annoyances with 2012 is I got data center on my host operating system. I still have to do key management. I still have to put keys into virtual machines. It's a pain. So now we've built this technology where Windows Server 2012 R2 comes up on an activated version of Data Center, and it just reaches out to the host operating system and says, are you activated? And if the answer is yes, then it's like, well, I'm activated as well. Yes. So I'm not going to demo this because it is the world's most boring demo. I bring up a VM and go, look, it's activated. But I will say there are a couple of common questions that I get about this. The first one is, well, is this tied to one of your channels? Like, is this VL only? No. No, if it's data center and it's activated, you got it. Whether it's OEM, whether it's VL, whether it's MAK, whatever. If it's data center and it's activated, you got it. The second thing, I actually had someone ask me about this and be like, well, I'm not sure I want this. Can I turn it off? Because I make VMs that I then give to someone else, and I don't want my keys traveling with it. And I had to explain to them, no, this is perfect for you because the VM doesn't have a key. You don't put your key in the VM. So if you're in a situation where you have VMs that come and leave your environment, this is fantastic. You run it in your environment. It will check that your host is licensed, and it'll run. You take that VM, move it to somewhere else, then that third party's hosts need to be licensed as well, and you don't have to worry about keys going back and forth. So really great functionality. So that said, let me switch across now and do some demos to show you what I've been talking about. So the first thing I want to do, I'm just running Hyper-V locally here. Got a couple of virtual machines. So I've got a Generation 1 and a Generation 2 virtual machine. And I want to show you a bit of what this looks like. Let me get that down. So this is going to be the world's most sexiest demo. I'm going to demo using Device Manager. When was the last time you saw a demo using Device Manager? This is fantastic. And I'm going to be a real nerd. I'm going to switch to the by connection view. So here I have my Generation 1 virtual machine, and if I go in here, what I find is, okay, I've got a PCI bus, and I love this. Off the PCI bus, we actually have our IDE controller, we have a Pentium 2 processor bridge, and we have a PCI to ISA bridge, which, believe it or not, VM bus is hanging off of the ISA bridge inside of the virtual machine. We did that so that we didn't have to worry about plug and play for this. But you can come in here and you'll see a whole lot of stuff. You'll see our COM ports, you'll see a floppy controller, a PS2 controller, whole bunch of stuff. If I come over to my Generation 2 virtual machine, you'll see, okay, that looks familiar, okay. But here, all I have now is VM bus. And everything is off VM bus. That's it. No ISA, no COM ports, no PS2 keyboards. So what are some of the advantages of this? Well, the first advantage comes obvious if I open up the settings. So hopefully you're familiar with this. You used Hyper-V. Look, it's Hyper-V virtual machine settings. That's not interesting. Let's go here. What's happened? Half the settings are missing because half the things are gone because they're no longer needed. So Generation 2 virtual machine, we can boot off of our SCSI controller now. So we don't need an IDE controller. We only have SCSI disks. We can boot off of our virtualized network adapter. We don't need a legacy network adapter. It's gone. It's a drastically simplified model of our virtual machine where we only have the virtualized devices. One other interesting thing that comes up is in order to do a Generation 2 virtual machine, we've actually built a virtual machine that uses UEFI firmware instead of a BIOS-based system, which we had before. And one of the features that we get there is we actually have the ability to have secure boot inside of a virtual machine now. So you can have protection against rogue kernel components inside your virtual machine, just like you can get on hardware. So a couple of things I'd like to highlight at this stage because I get a lot of questions about Generation 2 virtual machines. And I think they're really cool and exciting. However, a couple of key things. Generation 1 virtual machines aren't going away anytime soon. And you can run Generation 1 and 2 side by side, and we expect that many of you are going to continue to use Generation 1 because you need to run operating systems that don't support Generation 2 virtual machines. That's fine. The second question that I get is, well, what's the performance improvement to Generation 2 virtual machines? The short answer is really there isn't one. For day-to-day running, it's pretty much the same. There are a couple of areas, though. Operating system boot, about 20% faster. Operating system install, That is crazy fast. It's about 50% faster to install an operating system on a Generation 2 virtual machine than a Generation 1 virtual machine. Fun little test. Create two side by side and see what happens. So the real reason, real advantage of Generation 2 virtual machines today is being able to boot off of the SCSI controller and off of our virtual network adapter. It's also something that we're going to be investing in moving forward. So I'd really encourage you to check it out and see how it works for you. So with that, let me close those virtual machines. I'm going to bring up, I have a Generation 1 virtual machine with a cat in it because I like cats. Now, I'm a big, little side note, I hate seeing demos where people demo like 3 or 4 virtual machines and they all have the same desktop background. And halfway through the demo, you're like, wait, which virtual machine are they using now? They're going from... So I always have different desktop backgrounds. So this is a Generation 1 virtual machine, and I've actually set this up so that its network adapter is disconnected. So you can see that down here. And I'm going to demonstrate some of the capabilities of the enhanced virtual machine connection. Starting with what honestly I think is the most boring thing I have to demo here, and yet this is the one that everyone cares about, is if I talk to people about when do they use the virtual machine connection UI, they say, well, I use it when I'm troubleshooting. And I go, okay, so what frustrations do you have? And the number one thing that people come up with is, I hate the way you guys do copy and paste into virtual machines. So if you're familiar with this, you know that 2012 you do copy paste, and we do like the virtual ghostwriter for your virtual machine where we click and we type in the text and we only support text. Well, in 2012 R2 with enhanced virtual machine connection, I'm going to come in here, copy this rich text, paste, there we go. It worked. But as I said, honestly, that is the most boring demo I have because I can also copy and paste files in both directions. Okay? Well, now let's just be silly. I'm going to copy this file in, and I'm going to start it. And you're going to see something very odd if you're used to using Hyper-V. What you're going to see is you're going to see that I just copied in a video. I'm playing the video, and if the audio is working, I have sound. And let me highlight, no network connection throughout all of this. So how's that all possible? Well, let me explain in the only way I know how, and that is with block diagrams. Everyone likes a block diagram, right? Sorry, I'm a nerd. I love to do block diagrams. So here I have a diagram of virtual machine control in 2012. So I have my green is the guest operating system. Everything else is Hyper-V and parent operating system. I have an application in the guest operating system. It writes to a video keyboard driver in the virtual machine. And that then goes over VM bus, and it gets into the parent partition, into our worker process. And here what we basically do is we construct a frame buffer, big old bitmap that looks like the screen. And you can actually think of this as KVM over IP. That's what we deliver with VM Connect today. We give you a bitmap that's the screen, and we give you a keyboard and a mouse. Handy. And so that's what you connect to. You connect here, you get your basic experience. Well, what we've done in 2012 R2 is we've kept this overall flow. Because one of the big benefits of this overall flow is it works no matter what's happening in the guest operating system. It doesn't need network connectivity. It doesn't need yada, yada, yada. It works no matter what. So we've kept this overall flow, but critically, what we've done is we're taking advantage of remote desktop inside the virtual machine. So now, when I connect VM Connect to my virtual machine, what we're actually doing is VM Connect still connecting to the parent partition like it used to, and we're still going over VM bus like we used to. However, now instead of going over VM bus to our fake video card and our fake mouse and our fake keyboard, we're going over VM bus to remote desktop inside of the virtual machine. And this is where you get the enhanced experience. So a couple of things to point out here. I did not demo everything that you can do here because I will run out of time if I demo everything that you can do here. But this is full remote desktop. So what does that mean? One, smart cards. I can do smart cards into the virtual machine now. That works. Two, folder redirection. I can do that into the virtual machine. That works now. Three, this is the one that surprises everyone. Yes, we can do USB now. So it's the full remote desktop, but you don't need networking to the virtual machine. The final thing to point out here is I've demonstrated this running on my laptop, but because we go through the parent partition stack here, this even works if what I'm doing is I'm running the Hyper-V management tools on my laptop and I'm connecting to a Hyper-V on server core back in my data center. Even then, I can copy-paste files. I can get all this goodness. It's all there. Honestly, and side note, you spend one day using this, and you will hate using Hyper-V on 2012. I'm sorry. I've had access to this for a while now, and every time I go back to 2012, and I'm like, why can't I copy a file into my virtual machine? So anyway, so that's some of the cool future-looking stuff. So what else have we been working on? It should come as a surprise to no one in this room that, of course, we had a big focus on, okay, what can we do to continue to make Hyper-V even better for private cloud deployments? Anyone surprised by that? If you raise your hand, I'm going to make you leave the room. So, of course, we went back and we went, okay, 2012, great release for private cloud. Really is. But how can we make it better? So a couple of technologies came to the top. The first one, zero downtime upgrade. One of the things that was really foremost in our mind was, we got a lot of people out there who are really excited about 2012, and we need to make sure that we don't slow down their momentum. One of the things I actually talked about, and please, if you're in this category, come by the booth and chat to me. I would love to have a talk. One of the things that I talked about to the development team as we were planning the 2012 R2 release, I was saying to them, guys, next year I will be at TechEd, and I will have people in my session who are in the middle of a 2012 deployment. And if we come out with 2012 R2 and we don't have a fantastic upgrade story, I'm going to have abuse hurled at me a lot. So this was a big focus for us. Now, one of the things I'll point out, because it is no longer under embargo, we actually have a session, I believe on Wednesday, where we are going to be explicitly talking about the end-to-end story for upgrading your private cloud. We're going to step through how to do Hyper-V, how to do storage, how to do a system center, the whole enchilada. So if you are in the middle of a 2012 deployment, if you have 2012 deployed and you're thinking about how to get 2012 R2, come to that session on Wednesday. Really useful session. So next thing we did, faster live migration. This is really cool. I'll talk more about this in a demo that I have coming up. Online VHDX resize. This another common request that we got. Something that you're going to notice in 2012 R2, a lot of the features that we did are really all around allowing you to do things while your virtual machines continue to run. I always like to, I joke to the development team, I say, when it comes to system administrators and uptime, it's like kids and candy. You can't give them enough. And every release, we do more to increase the uptime, and every release, you guys just come back and say, okay, here's the next pain point. Please go work on that. That's good. One day we'll get to the stage where you never ever turn off a workload. That'll be a good day. I'll retire. So the next thing we did was the virtual machine live export and clone. And once again, I'm about to demo this, so I'll talk about it in this demo. No, I don't want the kitty cat. I want this one. Okay, so I have an environment here. I'm going to do a couple of live migrations. The first two take a bit of time. See, there's my demo playing up. Let me restart that. I believe I know what happened there. I bet I typed my password in wrong. I was worried about that. Okay. Let's get this set up again, and we'll kick off the first live migration as soon as that comes up. So in this demo, I'm actually going to do a series of live migrations. I'm actually going to do 4 live migrations in a row. So let's see if we're in luck this time. That looks better. Okay, we can see that that virtual machine has started live migrating. So this is going to take a little bit of time. So while it's happening, let me step you through my environment. I have, this is actually a lab running back in Redmond. As I said, most complicated demo I've done to date. I actually have a Windows Server 2012 Hyper-V cluster talking to a Windows Server 2012 scale-out file server cluster. Then beside it, I have a 2012 R2 Hyper-V cluster talking to a 2012 R2 scale-out file server. This is all running on the same hardware, and it's not very fancy hardware. I like to joke to Microsoft people that it is program manager hardware, because at Microsoft, the best hardware goes to the test team and then to the development team, and program managers grab the hardware as it's about to be thrown out. So this environment, I've actually just got a bunch of systems which are, they're single processor Core i7, and for the majority of this demo, the network backbone that I'm using is 4 1 gigabit network adapters teamed. So really nothing fancy, you know, kind of the entry-level infrastructure you would expect for this. So the first live migration that I'm doing here is actually a live migration just between 2 2012 servers. I've live migrated this virtual machine from the Clio server to the Calliope server. And I'm doing that just to give us a baseline for live migration in this environment. And for some reason, randomly, it gets stuck at 99%. I'll go past that in a moment. Once I've done this live migration, the next thing I'm going to do is I'm going to do a live migration from 2012 to 2012 R2 of the same virtual machine. And as I said, this is one of the big things that we want to show off. Now today, I'm just going to be doing a virtual machine memory only live migration. I'm not going to be doing a shared nothing live migration just because it takes time to move storage around and we don't have enough time for that. Let's just see, we got the time come up here. So it was 63 seconds for that live migration. We're going to kick off the next live migration. And this is, we're going to take the same virtual machine and we're going to live migrate it now across to my 2012 R2 server. This takes a little bit longer. We have to do some extra negotiation and some compatibility stuff. But the key thing is the virtual machine is going to be running the whole time so that I can upgrade my virtualization infrastructure without any of my users needing to be aware. This was one of the big things that we found when we were talking to people about upgrade was, you have the people who own the infrastructure and you have the people who own the apps, and they're different teams. And if an upgrade requires coordination between those two teams, then the reality is you're going to slow down your upgrade process a lot. So we want to build the system so that you could be upgrading your infrastructure independently of upgrading your applications. So a bit more details about my environment. The virtual machine that I'm live migrating is a Windows Server 2012 virtual machine. I have it configured with 6 gig of memory. I've actually disabled dynamic memory just to make the live migration times more consistent. If I have dynamic memory enabled, then it affects the numbers that come out at the end of the day. So I also have a simulated workload running inside this virtual machine. It's a test script that my test team put together in order to put some memory load on the system. So the other thing to know about this is I'm demonstrating cross-version live migration here. And for some reason, it's going very slow. We'll see what's happening there. I'm demonstrating cross-version live migration here. But in order to enable cross-version live migration, we actually enabled cross-version pretty much everything. So if you've done upgrades of Hyper-V servers in the past, you've known that we've had fairly draconian guidance about, like, your virtual machines have to be turned off, you have to have deleted any snapshots, you have to have, all these details. Upgrading from 2012 to 2012 R2, obviously our first recommendation is to use cross-version live migration. But if you're not using cross-version live migration, all that other stuff is now compatible as well. So if you have a 2012 server running Hyper-V, you have virtual machines with save states, with snapshots, you name it, you can just do an in-place upgrade. When you come back up, all those virtual machines are going to be there, all the save states, all the snapshots, all are fully compatible. You can use them just like nothing happened. In fact, it's one of the things that I really like on the desktop version. If you're running Windows 8, you have Hyper-V, you do an upgrade to Windows 8.1. Because it's a desktop environment, we don't even prompt you about running virtual machines or anything. So you have Windows 8, you have some running virtual machines, you do an in-place upgrade, we just go, fine, we'll save state the virtual machines, do the upgrade. At the end of the upgrade, we start those virtual machines automatically, and they're back up and running. And so it's like nothing happened to your environment. So that's actually really cool to see. So I have no idea why that took so long. I'm going to have to follow up and figure that out. So this is probably going to take another 30 seconds, unfortunately. So while I'm waiting for that, let me say a couple of more details about my environment. So the two clusters that I have here, they're configured using converged networking, so I have the networks teamed. However, since I'm only doing one live migration at a time, we're only going to be taking advantage of one of those. So these live migrations are effectively happening over a 1 gigabit link. And this live migration has finished, but we're stuck at 99% again. I don't know why this is. I practiced this demo this morning, and it worked fine without these timeouts. Apparently, I didn't make the right sacrifices to the demo gods. So we'll see. This will come up, and if it's consistent with times, the live migration will have taken about 90 seconds. It typically takes about 20 to 30 seconds longer to do the cross-version live migration than it takes to do the straight 2012 live migration. There we go. Oh, took a bit longer than 9 seconds. So key thing, virtual machine running the whole time. Now I have my running virtual machine over on Windows Server 2012. What can we do? Well, the first thing I'm going to do is I'm going to do a live migration with compression. So this is exactly the same infrastructure that we were using before. We're going to live migrate over my 4 1 gigabit network adapters. And this time, we're going to be using compression for the live migration. And thankfully, it's going faster this time. I was worried that it was going to sit at 5% like it did before. The key thing to understand here is this is actually the default option in 2012 R2 now. You install 2012 R2, we turn on compression for live migration. So without getting any new hardware, you're going to see a drastic improvement in live migration time in your environment. And what we do here is, as we're doing the live migration, we monitor how busy the physical system is. Because something we know is that most people's Hyper-V servers are actually not using all of their CPU these days. CPU is still underutilized even once you're virtualizing. So we monitor the workload on your system. We figure out if there's any spare CPU capacity. And we use that CPU to compress the live migration traffic and reduce the amount of data that's being sent over the network. So in just a moment, we'll get past. I thought I'd nailed this bug, but there we go. So 41 seconds. So we started with 62 seconds. We've now gone down to 41. But how can we make this faster? Well, I'm going to start a final live migration here. And this time, I'm going to send the virtual machine back to the other 2012 R2 server, but I'm going to change a bunch of settings in the background, and this time we're going to do the live migration. I don't think it heard my enter. Now we're going to do the live migration. This time we're going to do the live migration using RDMA. And what we've actually done here is we have built the ability to do live migration over SMB Direct. And this gives us a couple of things. One, it gives us access to the great RDMA networking offloads. But two, it also gives us access to multi-channel. So I actually have 2 SMB Direct enabled connections between these servers, and we're now going to live migrate the virtual machine back over both of those connections. So something to call out about the RDMA live migration is, unlike compression, where we're actually using spare CPU resource in order to speed up the live migration, with RDMA there is no CPU usage. We actually use significantly lower CPU for an RDMA live migration than we do for a standard one. And unfortunately, it looks like it's got stuck at 5%. So I'm going to jump forward, and we'll come back to this demo. Actually, we'll see. Unfortunately, I had this bug before. It's an issue with name resolution in my environment that causes these steps to slow down. So for some reason, I'm just not good at setting up DNS properly. And every time I hit this, it slows down the process. So I'm going to switch across to the PowerPoint slides, and we'll come back once that's completed. I'll have the times recorded for us. I want to give some more details about the different forms of live migration. So I've already talked about the compressed live migration. This is where we're effectively using your CPU resource to reduce the amount of data that we send over the network. So this is most useful in an environment where your live migration constraint is your network bandwidth. The other live migration we have is RDMA. And here we're using RDMA in order to speed up our network transfer. So this is actually more useful in an environment where your constraint is the CPU and the capability of the servers, and you've got plenty of network. And the general guidance that we're going to be giving here, to just make it simple, is how much bandwidth do you have available for live migration? If it's 10 gigabit or less, use compression. It's going to give you a performance boost. If you have over 10 gigabit available for live migration, use SMB or use the SMB Direct option to take advantage of multi-channel and of RDMA. So a really cool fact, unfortunately I don't have access to this rig for this demo, but a really cool thing about the RDMA-based live migration is when we were developing this, we actually took a couple of high-end systems and we were like, okay, what can we do to get the most performance out of live migration possible? So we took 2 systems, and we kept on putting more and more RDMA adapters in them to try and get faster and faster live migration. We started with an RDMA adapter on either side, saw great performance. We added a second one and saw even better performance. We added a third one, saw even better performance. We added a fourth one and saw no difference. So we're like, what's caused that bottleneck? So we went and we analyzed the system, and what we found was that the bottleneck that we'd hit was that once we got to 3 RDMA adapters, we were actually transferring the virtual machine memory at the speed of memory in the boxes. So we were bottlenecked by the memory bus in the servers and not by the network at all. So that's amazing to see. So I'm going to jump back to my demo. Unfortunately, I don't know what happened with the timing there, but I do want to show a couple of other features here. So I've got my Windows Server virtual machine. This is the virtual machine that we migrated from 2012 to 2012 R2. What can I do with it now? So there are a couple of things that we can do with this virtual machine while it continues to run. So I'm going to bring up the console so I can interact with the guest operating system. Okay, there we go. And I'm going to show you. So keep in mind, this is virtual machine started out on 2012. It's now on 2012 R2. It has not been turned off or rebooted at all. So the first thing I'm going to do is I'm going to come in here and I'm going to do an online VHDX resize. So this doesn't require any updates to the system at all. So I've moved to 2012, zero downtime, and I can already take advantage of this. I'm going to do that. It will apply. And my remote desktop session stopped responding. And there we go. I've got more space. I can take advantage of that online. So that's fantastic. And something to highlight, I can expand that partition now. I can also shrink it. So if I want to reclaim space, I could do that. Another thing that I can do is I can now do the export of this virtual machine while it's running. So if I go to, for instance, my desktop virtual machine here, I try and create a clone, it's not going to work. This is on 2012. We can't clone a running virtual machine on 2012. But if I come here on 2012 R2, I can clone a running virtual machine. So let me explain to you why this matters. There's a little story that I like to tell around this. And the story basically is, and this is, for anyone who's a server administrator, you'll know this story very well. You have a server workload running inside of a virtual machine, and you go to log into the virtual machine to do some basic maintenance. And as you're doing this, the management tool crashes with a strange error message. Exception in blah, blah, blah. And you look at this and you go, okay, something is clearly wrong with this virtual machine right now. And unfortunately, my UI has stopped responding, so I'm going to switch back from this. Demo gods aren't smiling on me right now. But something's going wrong with this virtual machine. However, for instance, it's a SQL server and it's still responding. You now have two bad choices to pick from. You can either go, you know what, the SQL server is still running, so I'm going to leave it alone. We all know if you make that choice, that in 2 hours that VM's going to fall over and die because something was wrong with it. People are going to come to you and say, what's going on here? And you'll be like, oh yeah, I logged into that 2 hours ago and things looked a bit screwy. And they're going to be like, what? Why didn't you fix it? Why didn't you look at it then? Whereas your other bad option would be like, okay, something's wrong, I'm going to take this virtual machine down and have a look at it. You're taking the SQL server offline, and all of a sudden, people will want to know why you did that. And we've all had times when, hey, maybe it was just a transitory thing. Well, with live export, you can now make a copy of that virtual machine while it's running and do your diagnosis without affecting the running virtual machine. Thank you. I'll take questions at the end. So what are the next things that we've worked on? So a big area of investment in this release was continuing to up our game for Linux guest support. And there are a couple of things I want to call out here. The first thing I want to call out is, and I have to state this to people because it surprises them, we do a fantastic job of supporting Linux as a guest operating system. We actually develop our integration components and release them under GPL as part of the kernel sources. So it boggles my mind when I get people going like, oh, well, I'm not going to virtualize Linux on Hyper-V because, obviously Microsoft is going to make it suck. Like, no, we actually do a lot of hard work to make it work really well. And we've done even more work in this release to make it work well. So we have full dynamic memory support now. And that's both hot add and remove. A lot of people see this and they're like, oh, they'll have just done ballooning. No, we've done the full thing like we have for Windows. We have online backup support. We have support for online VHDX resize of Linux guests. And we also finally have a virtualized video driver for Linux, so you get a better video experience, just like you do with a Windows system. The next thing we've done is storage QoS. So you have the ability to monitor the IOPS in a virtual machine and to restrict the IOPS. I'm going to do a brief demo of this, but I will highlight we have a storage session for Hyper-V later on in the show that's going to go into more detail on both storage QoS and on our end-to-end storage architecture. So if that's an area of interest to you, definitely encourage you to go there. The next thing we've done is the guest clustering with shared VHDX. This is actually, I think this is the biggest game changer we have in this release. Because you can now do guest clusters with exactly the same infrastructure that you deliver standalone virtual machines with. You no longer need to have specialized storage for your virtual machines. So now I'm going to do my second demo. And I apologize if you were in Jeff Woolsey's session, because I'm going to repeat the demo. My excuse is Jeff asked me to do a demo in his session at the last minute. So I just ended up grabbing this demo. So a couple of things I want to highlight. I'm going to give some more detail on it as I'm talking through here. So here's the demo that I did earlier with the I/O workload inside the virtual machine. Really interesting fact about this. So I've got my I/O workload running. I can bring up the settings for it, and I can play around with the storage QoS on it while it's running. So I can actually set this to pretty much anything, and it gets very accurately reflected. So I'm going to set it to 250. Hit apply, and it'll go straight down. An interesting thing about this demo is actually the storage that it's running on. So this is running on SAS JBOD chassis using storage spaces. But I actually have this demo running on a storage space on 2012 R2 that's configured using storage tiering. And the disks I have in the array are actually 10K spinning disks, each 300 gig in size. And then I have 250 gig SSDs. Now, I got those SSDs at the last moment. So I actually built this demo with only the spinning disks. And when I had the spinning disks in there, I would get about 1,500 IOPS out of this virtual machine. That was it. So I put 2 SSDs in there. I enabled storage tiering. And the thing that I found fascinating is every time I practiced this demo, it got faster. Because the first time I put the SSDs in there and I ran this demo, I was like, oh, look, we're getting up to 6,000 IOPS. Then next time I ran the demo, oh, we're up to 10,000. And as I kept on running the demo and practicing it, Storage Spaces was learning, like, oh, he keeps on hammering like this section of the disk and moved more and more of it into SSD. So now this whole section is in SSD and I'm running at native SSD speed. So I think that's pretty cool. So next thing to demo is some of the Linux integration. So I have a Linux virtual machine here. This actually has the video driver, so you'll see that I get the better mouse integration here. It also has the full dynamic memory support. So if I come here, this is virtual machine started with 1 gig of memory. You can see it's already ballooned down to about 800 meg of memory. And I have my handy little program here that's just going to chew memory for us. And each time you'll see that memory gets hot added to the system. And it is identical to what we do with Windows virtual machines. So you can run Linux virtual machines, Windows virtual machines side by side and get the optimal usage of memory in your environment. The next thing I want to demonstrate is the backup feature. This one I'm actually really excited about. To give some context, I actually have a number of friends and family, including my father, who runs Hyper-V and runs Linux on Hyper-V. So I get to talk to a lot of people about Linux and Hyper-V. One of the things that excites me about this option is we can now do online backup of, and I clicked on the wrong button. We can do online backup of Linux virtual machines with 0 downtime. So I'm going to make some people awkward here, uncomfortable here, and I do apologize for that, but sorry, we're going to go there. So how many people here do have Linux in their environment? Okay. How many of you have a good backup strategy for Linux in your environment? Yeah. I think that's 15% of the hands. Okay. Now, here's the real fun one. For everyone who has a backup strategy for Linux in your environment, can you raise your hand if you have a backup strategy for Linux in your environment which is not a script that just copies the files? 1, 2, 3, 4, 5, 6. 6 people. So, one of the things, and unfortunately this looks like it's going to take forever, so I'm going to give up on this. The demo gods are not smiling on me. Hopefully you were in the R2 overview, so you saw that demo work correctly then. One of the things that I've been saying to people about the Linux backup support in Hyper-V is, I'm sorry, if you use Linux today and you don't care about Microsoft, you don't care about virtualization, you don't care about any of this stuff, then I'm going to tell you, you should stick your Linux virtual machines in Hyper-V, because we have the best backup story for Linux now. Simple. You know, you can stick Linux in Hyper-V virtual machines. You can now use Windows Server Backup. You can use DPM. You can use any enterprise backup solution that supports backing up Hyper-V. And you will get full support for backing up Linux as part of that. So the next thing to talk about is disaster recovery. So easily one of the biggest features that we had people excited about in 2012 is Hyper-V Replica. We had lots of people using Hyper-V Replica, and of course when you have lots of people using a feature, you get lots of feedback. So we listened to a lot of that feedback, and we've added some key new features for Hyper-V Replica. We've added the extended replication, and we've added the finer grain control of replication. Now we have a full session later on that's dedicated to Hyper-V Replica, so I'd encourage that you go check that out. It's going to talk about these features. It's also going to talk about a lot of the real-world feedback and experiences we've got around Hyper-V Replica. But I am going to, even though the demo gods are not smiling on me, I am going to tempt fate and try and do one last demo so I can talk about some of the Hyper-V Replica features in detail here. So let's see how this goes. So I have this virtual machine file server. I'm going to enable replication on it. This should look familiar to anyone who's used Hyper-V Replica. I'm not going to send the page file. So the first change we made is the replication frequency. And in 2012, we only support sending replicas every 5 minutes. It was really interesting. We had people come back and say, that's too fast and that's not fast enough. So we've added a faster and a slower option. Now I know, so let me preempt, I know that when I get to the end and I have questions, the first thing that people are going to ask is, but I want to send replicas every 45 seconds. And I figured out in my environment that the perfect replication time is every 62.7 seconds. Yes, we know that people will want even finer grain control, but we have to consider our test matrix, and we believe this actually addresses most of the scenarios that people were talking about. So let me step you through why you want these options. So 30-second replication. What this means is it means that when everything's operating correctly, your replica virtual machine will never be more than a minute behind your primary virtual machine. Now, if anyone here has bought SAN-based replication solutions, you know you have to pay a lot of money to get that sort of replication latency today in hardware. So the primary scenario here is we had a lot of people come back and say, you know, replica's great and stuff, but, and I understand that you've designed it for small, medium business, doing it over, you know, a broadband connection. However, I'm an enterprise, and I'm actually doing replication from one side of my data center to another. You know, we just want you to send the data as fast as you want, and we don't care about bandwidth. We had people come back and saying, I'm doing replication inside a metropolitan area. I have 2 data centers in the same city with, you know, 10 gigabit connectivity between the 2. Let me do it as fast as possible. So that's what the 30-second option is for. The 15-minute option is the other end of the spectrum. We had people say, you know, I'm doing replica over satellite link. You know, I had a meeting a couple of months ago with a government department from Saudi Arabia where they were trying to figure out how to do this to locations in the middle of nowhere. And they were saying, we need replica to be really, really tolerant of the network going away for 20 minutes, 30 minutes, you know, an hour. So the 15-minute option means that we try and send data less often, and we're also more tolerant to network outages. So I'm going to go with 5 minutes, just jump through and finish this replication. So the next big feature that we added for replica was the extended replication. So if I come over here, I'm now replicating this virtual machine from Uterper to Hera. I've got it here. I can come in here and I can say extend this replication and send it on to Poseidon. Now there were two scenarios that came up for this, and I think both of them were kind of interesting. The first one was, you know, and this is the one that Jeff Woolsey talked about earlier, was we had hosters say, we want to offer replica as a service, but we want to use it ourselves. So now you can do that. You can have a small business replicating to a local hoster, and the hoster then replicating that virtual machine on to provide an extra layer of protection. The other scenario we had was we had enterprises who came to us and said, and by the way, the demo gods are really upset with me. This should be done by now. Ah, there we go. We had enterprises who came to us and said, well, we have a tough decision now because we have to decide between are we going to do a replica on-premise between our multiple locations, or are we going to do replica to a local hoster? This enables them to do both. They can do a first hop replication that is inside their environment, and then a second hop that goes offsite. So I'm expecting a lot of people to be using this and really excited about it. So in summary, a couple of things to take away. Hyper-V for private cloud, just getting better. You know, if you're happy with 2012 private cloud, you're going to be even happier with 2012 R2. Increasing virtual machine uptime, always a priority. I can guarantee you that whenever we release the next version of Windows Server, I'm probably going to be standing here talking to you about some new thing that we allow you to do without turning the virtual machine off. And at the same time, you know, one of the great reasons to move to 2012 R2 is just keeping those virtual machines up and running. Third point, we're always listening to customer feedback and refining features, just like with Hyper-V Replica. So please, if we have a feature where you're sitting there going like, Ben, this is a great feature, but you know, you missed the last bit. You need this extra thing to complete the detail. Come chat to me. Going to be at the show. Final point, innovating in virtualization. You know, we've got a lot of cool technology coming out here. I'm really excited to see how people use it. So with that in mind, I'd like to open up to questions. We have a couple of mics in the room, so if you want to ask a question, feel free to stand up to a mic. You have a person. Oh, let's go with the front one and we'll go with the back one next.
Okay, hi. When you demonstrated the clone of the running virtual machine...
Just a second. For all the people leaving, please remember to fill out evaluation forms.
When you showed the clone of a live running virtual machine, what happens when the clone is finished? Is the machine running or is it in a saved state? Because otherwise you have two machines with the same name on the network at the same time.
So a couple of good questions, and let me give a bit more details here. So we support live clone of a virtual machine. The cloning is a system center concept in the Hyper-V Manager. It's live export. We allow you to export or clone a running virtual machine. We also allow you to export or clone a snapshot or checkpoint of a running virtual machine as well. When you do the live clone operation, the resulting virtual machine is in a safe state. So you have the ability to go in there. Actually, not entirely correct. I have to give the more detailed answer. If you do an export in Hyper-V, or if you do a clone in SCVMM to your library, then the virtual machine is in a safe state. You can, through SUVMM, do a live clone of that virtual machine to another computer, and we will start it at the end of the operation. But you are right, you need to be careful about networking. When you go through the wizard for doing a live clone to another virtual machine, we give you the option to change the network configuration so you can disconnect it or connect it to a different network to make sure you don't have a conflict there. So
I noticed that some of the features you were describing, particularly the ones around the vMConnect, seem like they'd be really useful for client Hyper-V. So I was just curious if any of those features have been making their way to the client.
So absolutely. And in fact, something I should mention, whenever I demonstrate the remote desktop integration, I always have someone put on their tinfoil security hat and say, how can I turn that off? We've built that feature so that it is turned off by default on Windows Server and turned on by default on desktop. So we have a Hyper-V server setting where you can turn it on and off. But yeah, Hyper-V on desktop, the remote desktop integration really makes the experience a lot better.
Question. Hang on. What version of Windows InGuests will be able to take advantage of no key installs?
So the question is, what guest operating systems do we support the automatic activation feature for? Yep. So it is only Windows Server 2012 R2.
Okay.
So that's a 2012 R2 only feature, and it's Windows Server because we've only given licenses for Windows Server as part of the data center licensing.
Yes, the the Windows Server 2012 to 2012 R2 upgrades with no downtime. Does that include VMs that are part of a failover cluster?
So the question, I'm in the habit of restating questions. I don't need to do that because you're on the microphone. Yes, it does. The cross-version live migration I did today was actually between two clusters. So it was moving a virtual machine from the 2012 cluster to the 2012 R2. While I didn't show it today, you can do a cross-version, cross-cluster, shared nothing live migration in order to do an upgrade. So that's all supported.
Does that include within the same cluster, like migrating VMs to one node, upgrade the other node, and back and forth?
So the answer to that is quite complicated, but if you come to our session on Wednesday on upgrading your private cloud, we step you through all the options that are available for how to upgrade a cluster in place.
Thank you.
So come to that session and we'll go through all the details there. I wouldn't be able to do the answer justice in the couple of minutes we have here.
Dynamic memory, are you still doing the same thing? I mean, you add it very nicely, you swap memory and add to it a VM. To take it away again, are you still doing the same trick of ballooning up a process inside the OS?
Yes.
Yeah.
So yes, we are still using ballooning for removing the memory. We actually did analysis into doing proper remove, and ballooning was more efficient. So we'd like to do proper remove one day, but ballooning's the best option that we have available today.
I've got another related question on Azure services. So that got renamed the Azure Pack or something for Server 2012. What's going on there? I mean, the idea is you can just take a VM out of Azure and stick it into Windows Server 2012, and it's all Hyper-V these days, and the services all look the same, and it just sort of works, or is there more to it?
I was given explicit guidance from my marketing team this morning that I wasn't to answer questions about the Windows Azure Pack. So, sorry. Do we have any other questions? If not, I'm going to be down at the booth. We have an Ask the Experts session going on. So I look forward to seeing you all there, and I hope you have a good show this week.